sudden stop. And of course, the farther we fall, the more forceful and damaging that sudden stop becomes. Surviving the fall. The proper use of your personal fall arrest system. The proper use of a personal fall arrest system allows a worker to survive a fall with minimal injury by not only preventing the falling worker from hitting the ground, but also by limiting the amount of force imparted onto the worker when the fall is arrested. During this program, we're going to provide an overview of the proper use of your personal fall arrest system, while also pointing out some common mistakes you should avoid. The personal fall arrest system consists of three main components: an anchor point, a connecting device, and a full body harness. Each of these components is critical to the successful operation of the system as a whole. The Occupational Safety and Health Administration's general industry regulations require an anchor point be able to support 5,000 pounds or 22.2 kilonewtons of dead weight per person connected to it. 5,000 pounds or 22.2 kilonewtons is a lot of weight. An anchor point must be very substantial to be able to hold that much force. Do not use conduit, light fixtures, handrails, and similar objects as anchor points. These items are simply not strong enough to support the loads generated during a fall event. Using an improper anchor point can quickly lead to disaster. OSHA requires that the capacity of any anchor point used as part of a fall arrest system be verified by a qualified person. As a worker who must use a fall arrest system, you must understand which structures in your facility have been verified as approved anchor points. There are a variety of specialty devices available which can be used to create an anchor point. These devices must be marked as being rated for 5,000 pounds or 22.2 kilonewtons. But simply reading this label is not enough to verify that your anchor point is sufficient. When any type of device or component is used to create an anchor point, a qualified person must verify that the device, the structure to which it is attached, and the method of attachment to that structure all meet the load-bearing requirements. Let's now discuss the connecting device. The connecting device is used to provide a connection between the body harness and the anchor point. There are several types of connecting devices, including single lanyards of various lengths and styles, Y-shaped lanyards designed for moving between anchor points, and retractable lanyards, also called fall-limiting devices or retractable lifelines. Connecting devices which are part of a fall arrest system must be rated to support 5,000 pounds or 22.2 kilonewtons and must be labeled as such. Of course, a lanyard's strength rating depends on its proper use. Here's a common mistake: using the lanyard to cross over a beam or other object and then connecting back to itself like this. This is very dangerous because connecting a lanyard to itself reduces the strength of the lanyard by half. In addition, this exposes the lanyard to the sharp edge of a beam, which may cut or damage the stitching. Fall arrest equipment must always be protected from cuts, abrasion, and other damage. Protect your lanyard by using a beam strap or other device specially designed for this application instead. Also, do not allow a lanyard to become tied in a knot. Knots reduce the strength of the lanyard. And finally, do not use any part of your fall arrest system to move, hoist, or secure materials. Only use this life-saving equipment for its intended purpose. Connecting devices must also feature a double locking snap hook. A double locking snap hook requires two separate movements to release the keeper gate of the hook. A double locking snap hook is designed to prevent an inadvertent opening of the keeper gate. Operating this type of hook takes a bit of practice, so make sure you are proficient using it before needing to do so above ground. To ensure hooks are oriented for maximum strength during a fall and to prevent accidental disengagement, only connect a snap hook to a compatible device intended for this use. Do not connect snap hooks to rope or webbing, and do not connect it to wire rope or directly to a horizontal lifeline. Also, do not connect a snap hook to other snap hooks. In addition, do not connect two snap hooks into one D-ring. D-rings are only designed to accommodate one snap hook. Like any other piece of safety equipment, you should always inspect your connecting device prior to use. Look for any torn stitching, cuts, tears, frayed materials, burns, or chemical damage. Inspect the hook and keeper gate for any cracks, bending, or distortion. Look for any indications that the lanyard has been subjected to the force of a fall. Look at any energy-absorbing devices for signs of torn stitching or elongation. Lanyards and fall-limiting devices may also display a red alert tag or provide an indicator like this when it has been exposed to the force of a fall. Damaged devices or those devices exposed to the force of a fall must not be reused. Dispose of the damaged device and replace it with a new one according to your company's procedures. Let's now discuss the final component of our personal fall arrest system, the body harness. During a fall, the body harness is designed to distribute the shock load of a fall to multiple points on the body, reducing the likelihood of injury. In addition, the harness provides a support platform which allows the worker to remain upright and supported after a fall. Before putting on a harness, you must first perform an inspection. Check for damaged webbing, torn stitching, or distorted buckles and D-rings. Also, inspect for any burns or chemical damage. Inspect the harness for any indication it has been exposed to a fall. Damaged harnesses or those exposed to a fall should not be used and must be removed from service and replaced according to your company's procedures. Once your inspection is complete, it's time to put the harness on. However, sometimes it's hard to tell one part from another in order to get started. One way to sort it out is to find the back D-ring and gently shake out the harness so that it falls into shape. Once the harness is hanging like this, you can slip your arms through the shoulder straps using the same techniques as putting on a jacket. Next, place the chest strap about mid-chest and tighten. If the harness has a connected chest strap, you'll have to put your head through this hole to don it properly. If you have done it correctly, the rear D-ring will be located between your neck and shoulder blades. And finally, pull the leg straps around your legs and snugly secure the straps. Here's an important point to remember. Harnesses are designed to have a snug, secure fit while working above ground. A common mistake is to work with the straps too loose. This is especially true with leg straps. Falling with loose leg straps can be very painful and cause injury, as the straps are driven violently upwards into the groin area. When we mentioned earlier that it wasn't the fall that gets you, but the sudden stop, we weren't just having fun with an old expression. It's literally true. A worker weighing 225 pounds who is exposed to the full force of a 6-foot fall will generate around 2,500 pounds of force when stopped suddenly. Even when wearing a full body harness, workers can be severely injured by this level of force, even without hitting the ground. To prevent these sudden stop injuries, the Occupational Safety and Health Administration, OSHA, requires that a fall arrest system reduce the amount of force imparted onto a worker wearing a body harness to not exceed 1,800 pounds or 8 kilonewtons. One common method used to reduce the force during a fall event is to use an energy-absorbing lanyard. This type of connecting device features a section of material sewn together in such a way that it tears and elongates when exposed to excessive forces during a fall. As the material elongates, it absorbs the energy of the fall, slows the rate of descent, and brings the worker to a controlled stop. And with limited exceptions, OSHA regulations mandate that workers not be permitted to free fall more than 6 feet. This is why most lanyards are 6 feet long and are only designed to absorb the energy of a 6-foot fall. Here's a quick tip. To ensure that you do not exceed a free fall distance of 6 feet, you should always connect your lanyard to an anchor point located at or above the level of the D-ring on your harness. In other words, do not connect your lanyard to an anchor point below your D-ring. Doing so adds distance to your fall, which can cause you to fall farther than 6 feet, which places excessive force on your body and your fall arrest equipment. Another method used to limit the forces generated during a fall is to limit the fall distance. This is commonly done by the use of a fall limiting device, sometimes called a self-retracting lifeline. These popular devices allow a worker to move freely away from the anchor point and then quickly deploy a braking system in the event of a fall. In general, the smaller units have a rapid braking system which stops a worker's fall within 2 feet or less, while some of the larger units are designed to withstand a full 6-foot fall and utilize a gradual braking system to reduce the force of the fall over an additional 3.5 feet. As with all components of your fall arrest system, it's critically important that you understand your connecting device and how it is designed to operate. When used incorrectly, these devices will not prevent a falling worker from hitting the ground. And we'll next learn how this can happen and how to make sure it doesn't happen to you. Here's an example of a common mistake. This training mannequin was tied off 15 feet above the ground using a 6-foot harness. Yet, it impacted the ground with enough force to cause serious lower leg injuries. And let's learn why. To prevent hitting the ground during a fall, workers must be able to calculate their total fall distance. The total fall distance is the maximum distance a worker will fall from the anchor point. To calculate this distance, you must add the worker's height plus the lanyard length, plus the elongation length of any energy-absorbing device or braking mechanism. OSHA mandates that the maximum elongation or braking distance of energy-absorbing devices be 42 inches, which is 3.5 feet. The total fall distance for this 6-foot worker wearing a 6-foot energy-absorbing lanyard with a designated elongation of 3.5 feet is 15.5 feet. After adding an additional 3-foot safety factor to our calculation, we see that our anchor point must be a minimum of 18.5 feet high for a 6-foot worker to safely use this type of 6-foot energy-absorbing lanyard. 18.5 feet is pretty high. It's also a distance that is hard to estimate visually, so if you're unsure, measure it. Of course, there are many situations where a worker is exposed to a fall hazard at heights less than 18.5 feet. In these situations, workers can use a shorter lanyard, but a more common solution is to use a fall limiting device. As we mentioned earlier, many fall limiting devices will stop a falling worker in 2 feet or less. This greatly reduces the amount of force placed onto the falling worker. When using one of these devices, it is extremely critical that the anchor point be at or above the level of your back D-ring. Connecting these devices below the D-ring not only adds to your free fall distance, but will allow you to free fall farther than 2 feet and may exert a force onto the device which exceeds its design limits. Another common mistake when using a self-retracting lifeline is moving too far away from the anchor point. It's possible to extend the length of the retracting lifeline beyond the height of the anchor point. When this is the case, you will hit the ground should a fall occur. In addition, even if you don't hit the ground, moving too far from the anchor point causes a large swing arc during a fall. A large swing arc can cause you to strike objects with great force during a fall event. To prevent these types of incidents, a good rule of thumb is to keep your lifeline within a 15-degree angle to the vertical at the anchor point. Remember, the purpose of your fall arrest system is for you to survive a fall with minimal injury should one occur. Unfortunately, The most common mistake workers make concerning their fall arrest system
Nah, I'm good, man. We ain't gonna be here that long.
is failing to connect to the anchor point when above ground. Far too many workers have fallen to their deaths while wearing a perfectly good body harness because they simply failed to connect it to the anchor point. Another common mistake is temporarily disconnecting your lanyard in order to move to another anchor point. Utilizing a Y-shaped lanyard to connect to a new anchor point before disconnecting from the current one allows you to be tied off and protected 100% of the time. Be aware that a proper Y-shaped lanyard is manufactured with a single snap hook to be connected to the harness D-ring. Recall that connecting two hooks to one D-ring is prohibited, so do not use two separate lanyards for this purpose. Ultimately, surviving a fall depends on you and your decision to properly use your fall arrest system every time it's required. There is, however, another potential element to fall survival that many people fail to consider: the rescue. After a fall has occurred, a worker will be left hanging in their harness, often at a great height above the ground. This can present a challenge for a prompt rescue. A prompt rescue is critical because the effects of hanging in a harness for an extended period of time can be fatal. These potentially deadly effects are called orthostatic intolerance. Well, it's commonly referred to as suspension trauma. When our body is hanging in a harness, blood accumulates in the veins of the legs due to gravity and a lack of movement. This pooled blood continues to accumulate over time and reduces the amount of blood available for circulation. A lack of blood flow leads to a loss of consciousness and damages vital organs such as the kidneys, leading to renal failure and eventually death. There are many factors which affect how quickly suspension trauma will occur. But OSHA's Safety and Health Information Bulletin, SHIB 324-2004, updated in 2011, states that suspension in a harness can result in unconsciousness followed by death in less than 30 minutes. While awaiting rescue, a fallen worker may help prevent suspension trauma by periodically pumping their legs up and down, which helps return some of the pooled blood in the legs back into circulation. However, the effectiveness of this method is reduced by the compressing action of the leg straps. There are simple devices available which can be connected to your D-ring, which provide a step on which to stand and straighten your legs. It's easy enough to make a similar device by carrying a proper length of rope, tying it in a knot, and securing it through your D-ring. If your rope is the correct length, it will provide a loop onto which you can place your foot and straighten and pump your legs. Standing up and periodically pumping the legs is more effective in preventing suspension trauma and relieves the pressure of the harness straps on your legs and thighs. Be aware that once you fall while wearing a harness, the pressure on the harness straps may block your ability to access your pockets or other storage areas. Make sure you place your rescue equipment in a location that can be easily accessed after a fall. There are a wide variety of rescue methods which can be used to safely retrieve a fallen worker. Before working above ground and using a fall arrest system, make sure you understand your facility's rescue plan.
Get him up, get him up.
Perhaps the simplest method is to have a coworker, who must also be wearing a proper fall arrest system, assist the worker back onto the level from which they fell. If this is not possible, a worker may be quickly recovered using a ladder or a mobile work platform. Of course, for this to be effective, the ladder or mobile platform must be nearby and of suitable height to safely reach the worker. Having appropriate rescue equipment nearby should be part of a proper rescue plan.
Rescue system coming to you.
More elaborate rescue plans may include connecting the worker to a rescue line,
Prepare to lower.
and lowering or raising them to a safe level. This type of rescue requires trained rescuers be available with immediate access to rescue equipment designed for this purpose. Surviving a fall means being prepared to fall 100% of the time that you're working above ground. And this not only requires properly using your fall arrest equipment each and every time you work at height, it also requires an elevated commitment to your own personal safety. After all, having a sky-high commitment to personal safety and fall prevention is the only way to make sure that you safely return to solid ground. Now, go have a good day and a safe day.